Hi everyone. I restarted the STKO to continue series of the time series discussion. So without wasting any further time, let's go to the time series and uh, we discussed up to linear and then this is a discussion on the path. So for the path time series, we have some choices whether we want to be a constant or a non-constant uh, time series. Now the difference between the previous time series and this time series is that it actually consider the interpolation in the analysis. So we have an optional factor to multiply load factors, and we have optional starting time. By default, it takes it to be zero, and this is the vector here. So, for example, if I have three values, one, two, and three, right? So what it do basically, and this is the 0 point. This is t value. So with zero, it means that if this is zero, it's a constant function. If I make it 0.5, I will get a linear function with a slope here. And this is the factor here. The vector that I defined here, uh, it is up to 3. So if I change it here at this point, at the starting point, for example, if I want to start from 0.2, so look at here, it will start from 0.2 and reach to 1.2 here. And after that, the constant factor currently it is a value. It has a value of 3. If I change it to 3, it will convert to 9 because we have a factor definition here. And dt is let's say if I want to make it 0.1, so with 0.1 it will change accordingly to itself. So something like the previous one, but in this, if we provide this definition here, it actually consider the interpolation here. So for the part time, we can find out details on the OpenSees documentations as well. So the difference between the previous one and this one is the scheme by the interpolation here. So if we have input points, we can use this to construct a path time series object, and I think the relationship between the load factor and time in input is defined here in terms of series here. So we can define multiple values. For example, if I change it to 1, I change it to 5, I change it to 2, and I can now define these values here. So what is happening here in this plotting option here, why we are using it? Because we have a bigger opportunity by taking advantage from the OpenSeas interpolation. So if there is any missing value in this time series, the OpenSeas will be able to interpolate this value and use it in the analysis inside the STKO. So these are the tags, right? And we can define various kind of time series paths here, and these are the values that are present here. So after this, we have uh, a, a, a peer motion option here. So this is the peer name of the earthquake. If it is in California or any other station, you can use this, and we can then reach to the peer motion, peer ground motion. But I think this link is broken here. So if I go to peer strong motion database, this will be not available here. So this is the web page. The previous link is broken, um, and these are the details. Let's say if it is given here, uh, this is NGA waste to ground motion, and we have this documentation and all those steps available here with us. So just in case if you want to use them, we can use them here with the earthquake that is an active tectonic regime here. And for the station, if you have information about the station where it is station 5, 6, 7, 8, whatever, with the direction and the station name abbreviation, we can include them for our ease. And here we can either use displacement or we can use acceleration here. The factor, just in case if you want to specify a specific value of g, for example, if you want to make it double in the response to check for the probability event, we can convert them. And these two are optional. These are for a number of points, and this is the step interval in between 2 points and the time series. And we can define the number of points from the data points and dt based on the analysis procedure. So it will interpolate according to this dt. If we do not provide it, we will use the same. The OpenSees will use the same point, and perhaps the convergence issues will occur. After that, we have here NGA motion that is specially to, to base NGA West 2 and NGA East data, right? And similarly, we have these other information, so we can go to the database component here. The details are given here. We can also go to the East, but the East is not included here. So it's like for the pure ground motion, then this one is for the pulse. Pretty simple. If you want to keep the impact of a force for a certain period and then reduce it and then increase it and then reduce it, then we can do it. We can decide the width, we can decide the shift, we can decide the factor and the starting time. For example, if I want to start it from 1, it will be started from 1 and in on 2, then it will in on 2 and starting on 1. And the period is, for example, 1.1. So for each step, we have a 1.1. If we make it zero point 0.2, we will have that period accordingly adjusted here. And the width will be the width of the interval here for the impulse, the top one. For example, if we change it to zero point 0.3, we can look at here. And then for the shift, for example, if I want to shift them with 1, then this shifting has occurred here. And also, if we have a scale factor and we want to make it a double amplitude, we can control them here. After that, we have this rectangular scheme. So I'm not going to any details. It is self-explanatory. You can see them starting. For example, if I make it 100, we can keep this adjustment according to our input requirements. And after that, we have this triangular load pattern. We have starting point, ending point, and we have this period of let's say 5. We can use the shift of, for example, 1. We can use the factor of, let's say, for example, 5. So we have all these input information. We can control them according to the time series that we are trying to perform our analysis on. And similarly, we have trigonometric function for the shift in all those steps. So just in case if you are watching this, you will have a better idea of how it is working in your analysis. So, and this way you can use the STKO time series for the OpenSees and you can work with it. So make sure these two are not discussed here. This one miscellaneous and random variable due to the server kit issue. And in the next video, I need to go to the most important topic, that is physical property. And for the physical property, we will discuss three main topics here: material, the sections, and the special purpose elements here. These three will be discussed, and after that, we will discuss the element properties. So, this is a very interesting topic, and it's my favorite. This video series. So, when you understand this, you will have an idea of the OpenSea syntax, and then I think we have discussed the conditions, we have discussed the mesh analysis is remaining. So this after the completion of this whole discussion, I will try to solve the issue of uh, the solver kit, just in case if it is solved, then the issue is not that much difficult to resolve. However, there is a compatibility with the operating system, so I cannot find a solution now, and I have to search for it whether in the STKO forums or OpenSeas forums to get the idea of it. And I think after that, we are ready to start scripting in the OpenSeas and do analysis on the overseas. So, anyways, it's a good initiative. I think if you start working on it, you'll be able to get the idea of how you can do it. So, thank you so much for watching. Have a good day.